This is a video about learning how to draw Lewis structures for covalent compounds that have single covalent bonds. So if I look at, this was one of them I think you did in your POGO. Fluorine, it has one covalent bond, and let me show you. So notice that right here is what we call a single covalent bond, which is one line like that is the same as 2 electrons. So you did this in 9th grade, but they taught it to you in a different way than I'm going to teach it to you. I'm going to highly recommend that you do it my way. Otherwise, you will get to some, eventually, not right away, but eventually you'll get to some structures that you won't be able to draw. So really try to forget how you learned it and do it this way. This is kind of a college level way to draw Lewis structures that I think that you'll find is still pretty easy. But you do have to practice. So these are the steps that we're going to follow. The steps are that we're going to add up all of our valence electrons, which we're going to call an electron cache, like a storage of electrons. We're going to use, we're going to form bonds between all of the elements. And if there is more than 2, you want to put the element that has the most unbonded, unpaired electrons in the middle. For example, if I have carbon, which we know has 4 valence electrons, so it really has like 4 openings, places where there's unpaired electrons, I would pick carbon to be in the middle versus if I was going to do chlorine. And chlorine only has 1 unpaired electron spot right here. So you're going to get better at that too, and we'll see more examples with this also. So once you've drawn the bond in, then you're going to subtract those electrons that you used in the bond from the electron cache, and then you're going to arrange the remaining electrons around each of the elements in pairs so that everyone ends up with an octet or a duet of electrons if it's a smaller element. So let me show you what I mean. So here are some things that we're going to be, they're all covalent compounds that we're going to draw the structures for. So following those rules, the first thing is we're going to figure out how many total electrons do we have. So we know that we have 2 hydrogens, and 1 oxygen. And we know that hydrogen has 1 valence electron, and we know oxygen has 6 valence electrons. So this gives us 2 and 6 for a total electron cache of 8. So that's like how many electrons total do I have to start with? The next step is, now we have 3 elements. We're going to pick oxygen to put in the middle, because if you visualize oxygen, if you were to draw just the E dot, you can see it has 2 unpaired electrons, and hydrogen only has 1. And you're going to get used to this. Hydrogen will only bond 1 time and then it's done. It can't bond anymore. So I'm going to put the oxygen in the middle, and then I'm going to put the hydrogens on the side. Remember, this line is really 2 electrons, and it's called a single covalent bond, or a single bond. So I used a total of 4 electrons. So I'm going to take my cache, 8, and I'm going to subtract the 4 that I used. So I have 4 electrons left over. So the hydrogens, at this point, the hydrogen over here has 2 valence electrons. This hydrogen over here has 2. And that's okay. Hydrogen is really small. So a duet, or 2 valence electrons, so they really have that full S2 like helium, that's good. It's okay. This oxygen, however, has only 4 valence electrons. So it's a bigger atom and it wants to have 8. So that's where I get to now place these 4 electrons. And I place them in pairs. So I'm going to go here and here. So now this middle oxygen has 2, 4, 6, 8 valence electrons. And it is stable. So I'll put a little smiley. You don't have to, but just so once everyone has their either duet if they're small like hydrogen, or their octet like most other elements, 8 valence electrons, then they're stable. So let's draw another one. This is hydrogen with fluorine. Let's figure out the cache. So this time we have just 1 hydrogen, 1 fluorine. Hydrogen has 1 valence, fluorine has 7. So we have a total of 8 electrons for our cache, our total number of electrons. Then, remember, my next step is just to create a bond, and this time there's only 2 elements, so I only have to create 1 bond. This line, remember, is 2 electrons. So once I form that, I'm going to subtract those 2 electrons from the 8, and I have 6 remaining. Then I want to think through, where am I going to put those 6? Remember, hydrogen is already stable with just 2, so I don't want to add those electrons to hydrogen, ever. It's a really small atom, and it can only handle those 2 electrons, and it is like a noble gas. It's like helium. So then I'm going to put the other 6 electrons around the fluorine, because right now the fluorine only has these 2 electrons. And fluorine's much bigger. So I would add 2, 4, 6. I just placed those 6 electrons around. So now fluorine has 2 here, 4, 6, 8 valence electrons. It has an octet. Hydrogen has 2. Notice how they're both able to count these electrons that they're sharing, and everyone is stable. Let's do another one. So this is nitrogen with chlorine. I'm going to calculate my cache. I have 1 nitrogen, 3 chlorines, 7 valence electrons for the chlorine, 5 valence electrons for the nitrogen, which adds to a total of 26 valence electrons. So my cache is 26 to start with. Then I'm going to put the nitrogen in the middle. Again, here's my thinking. Nitrogen has 3 unpaired electrons. Chlorine only has 1 unpaired electron. So chlorine and the other halogens, group 17, they only bond 1 time, just like hydrogen. So you never put them in the middle when you have more than 2 elements. So I'm going to put the nitrogen in the middle, and I'm going to bond to each of those chlorines. So remember, each line is 2 electrons. 2, 4, 6. I used up 6. So I have 20 left. Now here's where the rules are really important, and it'll matter as you do more and more of these. So I have 20 electrons in a sense, I think, to spend, to use up. You want to place them around the outside atoms, and then if you have enough, you go to the central atom. So I'm going to place them in pairs, 2, 4, 6, 8, 10, 12, 14, 16, 18, and I do have enough to go here now. So now I double check. This chlorine over here has 2, 4, 6, 8, so it's okay, it has an octet. This chlorine down here, 2, 4, 6, 8, it's good. Over here, 2, 4, 6, 8, and then the nitrogen, 2, 4, 6, 8. So everyone's fulfilling the octet, and this is a good Lewis structure. Before I go to the next one, let me talk to you about polyatomic ions. Polyatomic ions are, they're ions, but within the formation of a polyatomic ion, the bonds are covalent. So on your mole map, if you go to the back side, you can see many different polyatomic ions. On the left, there's this NH4 is one of them. So it's nitrogen with 4 hydrogens and a positive overall charge. So what that means is you're going to have one less electron than you would have if you were to add all the valence electrons, or all of the, well, if you add all of the electrons up, you'll have one less. If you have a negative, like let's look at this chromate, CrO4 is -2. That means you're going to have 2 more electrons added. So one, if it's positive and that's the only positive one we're going to deal with, you would have 1 less electron. But if it's negative, in -2, you'd have 2 more electrons. If you have -1, that means you have 1 more electron. If you have a negative, let's say phosphate has a -3, that means you have 3 additional electrons. So this will make more sense once I do the problem with you. So the problem here is, we're going to do everything the same. So we have nitrogen, we have 1, hydrogen, we have 4, 5 valence for the nitrogen, 1 valence for the hydrogen. So when I add these, I get 9 electrons. When I do the cache, it's never going to be an odd number. So that's a good giveaway that I need to do something. And what I need to do is remember, if it's positive, I'm going to have 1 less electron. If I were to add all the electrons and protons, I have 1 less. So that means I'm going to take 1 away here. So my cache is really 8 electrons. So then I follow the same rules. And now I'm going to put the nitrogen in the middle. I never put hydrogen in the middle. I'm going to single bond to those hydrogens. I'm going to figure out I've used up 2, 4, 6, 8 of these electrons. So I have 0 left over. So I don't have any that I need to place. I'm done, because look at the hydrogens each have 2 valence electrons, and the nitrogen has 2, 4, 6, 8, which is good too. The only other thing is, because it's an ion, we want to make sure everyone knows that, and it's getting a little messy here, but I would put brackets around it, and then let me get rid of this part from the previous drawing so that you can really see it. And then I would put the charge on the outside of the brackets.